All right, so the block is whirled by two ropes. The tension in rope one is just equal to the object's weight. So T1, there we can see, whoops, go away. Well, that's fun. We can see that T1 is mg, so we know that. Find the block's radial acceleration. So we want to find this a sub c. All right. So with that, gosh, this is interesting. Yeah, so we just got to do a force diagram. That's gravity down. Then there's this T2, and then this T1. So we have this mg, that T2, and that T1. This is mg, and T1 is also mg, so we know that. The big one, this, is 47, and that one, or sorry, 45, and that's 37. So if we gauge here, do it something like this, so it's a little bit easier to see. Okay, that's mg, that's mg, that's T2, that's 37, and that's 45. Wow. Okay. So we just now have to do some of the forces, and the sum of the forces in the y we know to be what? Thank you. Okay. The two vectors can be broken up into those pieces. Does that make sense, Ray? And thank you, Travis. Okay. So we've got something like this is, that's T1x, and this is, okay, T1y, and this is T2y, and that is T2x. Okay, from these things, we can also make some statements. We know that T2y basically plus T1y equals mg. Does that make sense? Questions? Okay, then Kate, what must the sum of the forces in the x equal? Okay, so if I say the sum of the forces in the x equals, now what Kate did is she said it's got to be T1x plus T2x. T1x plus, why is this T2x. Now, that's what, yes, this is what I'm adding up. But what must that equal? What must that equal, Michael? Well, let me ask you this question, Mike. Okay, that's strange. I don't know why that did that. Mike, if you looked at this from the top down, how would you describe the path of that block? Circular. So then, in the x-plane, if I'm looking from the top down, you're saying that's moving in a circle. So what must the sum of the forces in the x be? What do you think, Mike? Okay, so it's got to involve a sub c, or a sub r as the book calls it, right? And then, of course, Justin's right. It's m, okay, it's mv squared over r. Does this make sense to everyone? Okay, what did I say about anything, anywhere in the universe, anytime moving in a circle? The sum of the forces are ma sub c or mv squared over r, always. okay? If you look at this vertically, it doesn't do that. Vertically, it kind of doesn't move at all. But horizontally, in the horizontal plane, right, it moves in a circle. So then that gives us mv squared over r. Yeah?
How do you know the A sub C or
Okay, hang on. Tiffany, what's the difference? Is she just set it up, right? A sub c is v squared over r.
Oh, and then
Yeah.
oh, okay.
Right, so thank you. A sub c is defined as v squared over r. Does that make sense? Okay, so from this now, we can, okay, oh, sorry. Let me back up a second. We're supposed to find a sub c, aren't we? So I probably shouldn't, oh man, seriously? Ugh. Well, let me erase. So we probably shouldn't, we should just leave it m a sub c. Like if we were trying to find the tangential velocity, then we'd fill that in. But they asked for a sub c, so we should leave it like that. Okay, so if we go back over here, T2y and T1y is going to be T1 and T2 and then whatever sine theta or cosine theta as the case may be. What we have now is we have T2y plus T1y equals mg, and we have T1x plus T2x. Man, this is terrible. Writing with this is worse than my finger. Let's see, I'm just going to use my finger, I guess. Okay, so if we have T1x plus T2x, that's going to equal m a sub c, right? So now we can start filling these things in, right? T2y is what? That's going to be T2, so that's T2, and then the T2 is 45 degrees, so it doesn't really matter, but I'll go ahead and I'll pick cosine 45 degrees plus T1. And do you remember what T1 was? They said T1 was mg'd, right? Yes. Yes, okay. So T1 is mg, and then that's going to be sine 37 degrees, and that equals mg overall. Then for T1x, we're going to say mg cos 37 plus T2x, which is going to be T2 sine 37. Oh, just kidding. It's not 37, sorry. That one's 45. And then that's going to equal m a sub c. And do you see what we're going to do here? How are you going to solve this? Tiffany, what do you think?
Figure out what T2 is.
There you go. Just plug in T2 from the top, substitute in the bottom, and we're good, yes? So then you'll get some big, nasty, ugly thing, but whatever. I think you could just do it by numbers if you wanted to. Let me see, what was the mass of the thing?
It wasn't given.
Oh, it wasn't given? Oh, yeah, look at that. It's going to cancel out of everything when we so, okay, I guess I got to do this nasty algebra. T2 is going to equal to mg times 1 minus sine of 37 over cosine of 45, right? And then that is going to get plugged in. So I'm going to get mg cosine of 37 plus, and when I substitute that in, I'm going to get mg, and that's going to be tan 45 times 1 minus sine of 37 equals m a sub c. And then that lets me cancel m's, and I get a sub c equals all that gibberish. And now let's just plug everything in. Cosine of 37 is 0.8. Tangent of 45 is 1, so that goes away. Sine of 37 is 0.6, so that becomes 0.4. So this becomes 0.8g plus 1 minus 0.6 G, which equals what, 1.4 G, and that's A sub C, which is gonna be around 14 meters per second squared. Yeah, so my answer should have come out to be about maybe 1.2 G, I'm guessing, which would give us the 11 meters per second squared, which is the answer. But it's all the right logic, but thank you, Irvin, for watching out for us there. Questions?